Ever wondered how AI systems figure out if a statement is true or false? It's not just about crunching numbers, it's about interpreting meaning. Let's dive into how researchers build the rules for this kind of logical thinking. At the heart of this work are interpretations. Think of them as the dictionary that gives meaning to symbols and rules. An interpretation has two parts: a world of individuals, like people, places, or objects, and a set of functions that assign truth values to statements. For example, if we say Socrates is a man, the interpretation would map Socrates to a specific person, and is a man to a property that applies to them. Now here's where it gets interesting. When evaluating complex statements, like if all humans are mortal and Socrates is a human, then Socrates is mortal, the interpretation uses special rules. These rules, called logical operations, handle negation, conjunction, and quantifiers. For instance, negation flips truth values, like turning true into false and vice versa. Conjunction and combines truths, while disjunction or spreads them. Quantifiers like for all or there exists check every individual in the world or just some. But here's the twist: real-world knowledge isn't always clear-cut. That's where paraconsistent interpretations come in. Unlike classical logic, which collapses into chaos when contradictions arise, paraconsistent systems let us reason through inconsistencies. Imagine a statement like, "This sentence is false." In classical logic, that's a paradox that breaks the system. But with paraconsistent reasoning, we can say, okay, there's a contradiction here, but let's still explore what this means. So how does this apply to AI? Researchers are training models to act as interpreters, mapping abstract logic onto real-world data. For example, if an AI says, "Einstein invented the light bulb," the interpreter checks, is there evidence for this? Is there evidence against it? The answer isn't just true or false. It has a nuanced score like partially false or unknown. This is the essence of bilateral evaluation, weighing both sides of a statement. But here's the challenge: AI doesn't always know when it's unsure. It might default to ambiguous answers instead of admitting uncertainty. That's why researchers are building systems that force AI to justify its reasoning, using logical rules to flag gaps in knowledge. It's like teaching a robot to say, "I don't know," without just guessing. The goal? To create AI that doesn't just memorize facts, but understands them, reasoning through contradictions, adapting to new information, and explaining its logic. It's a bridge between human intuition and machine precision. Now here's where it gets interesting. How do we actually measure whether an AI is getting it right? It's not just about flashy answers. It's about evaluating how well those answers hold up under scrutiny. Let's break down what these numbers mean and why they matter. Imagine you're hiring a fact-checker. You want them to be accurate, thorough, and efficient, right? That's exactly what these metrics are, like a report card for AI models. There's macro F1, which measures accuracy, think of it as a test score, coverage, which shows how thoroughly the model checks its work, and time and tokens, which tell us how fast and resource-friendly the process is. Look at the results. For example, when evaluating GPQA questions, the Llama 4 Maverick model scored a high macro F1 of 0.774 when using a direct prompt, but it took over 6,000 tokens and nearly a minute to process. Meanwhile, GPT-4o Mini was lightning fast, just 16 seconds, but its accuracy dropped. It's a trade-off between speed and precision. Now here's where it gets interesting. When the goal was unilateral factuality, checking if answers are 100% accurate, some models like Claude 3.5 Sonnet and Llama 4 Scout hit perfect coverage, meaning they checked every answer. But even with that thoroughness, their accuracy varied. This shows that checking is one thing, but getting it right is another. What does this mean for real-world AI? If we're asking models to self-assess, we need to balance speed, accuracy, and thoroughness. Some models excel at one but lag in others. And the zero or few prompts. Those are like giving the AI a hint. Sometimes it helps, sometimes it doesn't. So whether it's interpreting meaning or evaluating performance, the future of AI lies in its ability to reason, adapt, and justify its decisions. Thanks for watching. If you want to explore how AI interprets meaning, hit subscribe. And drop a comment. What's one logical puzzle you'd love to see an AI solve? Let's keep the conversation going.